Hello everyone. In this video, let us see an important interview program from linked list, so called middle node of the linked list. So that is accessing exactly the middle node of the linked list. So program number is 876. So it's from easy level. Okay. So observe the problem statement. So here everyone carefully. So given the head of a singly linked list, return the middle node of the linked list here. Okay. So fine. Observe the second point here everyone carefully. So if there are two middle nodes, so return the second middle node. Okay. From platform to platform, actually this program differs. Okay. In some platforms, so in this one asked as so to return the first middle node. Okay. So here it is given that return the second middle node. Okay. So actually, there is no problem with the odd length linked list. Okay. So for odd length linked list, so you'll get only one middle node. Okay. So but for even length linked list, we are going to get two middle nodes. Okay. In that scenario, so for in some platforms we need to return the first middle node. In some other platforms we need to return the second middle node. Okay. So here in the example one, so the exact middle node is so 3. We need to return it. Okay. So on returning, so that so enter whatever the values attached to that next to that also returns. Okay, the same thing you can observe in the output. Don't confuse. Just on returning, so this middle node address, okay, reference. So whatever the nodes connects to this one also going to be returned. Okay. So if you observe example 2 here, this is an example for even length linked list. Okay. So here two middle nodes were there. Okay. We need to return so the second middle node here. Okay. So I'll explain so how to return so the first middle node also. Okay, first let me complete so this one. Okay, so returning second middle node. So actually this is very important one. Okay, based on this, here you are going to observe two-pointer approach. Okay, so for designing this, so famous program approach is there, that is rabbit and tortoise approach. Okay, so hooray and tortoise approach you are going to observe. Based on this, we can design so the most of the programs here. Okay, uh, you are going to observe later on this. Now let me so explain so with the help of an example. Okay, so fine. Let us take so linked list here. One, two, so three, next four, and next of also five, and five next is connected to so null actually in so remaining language in Python it's a none. Okay, so fine. So here what I said, we need to find the exact middle node, right? Okay, so you are going to observe the two-pointer approach here. Okay, so that why I said that rabbit and tortoise approach. Okay, so you know that so tortoise moves slowly and so rabbit moves quickly, right? Okay, so here regarding so those two, so we are taking so the pointers here initially to the head node. So this is the head node, right? Okay, so to the head node, so we are going to take so the two variables so called uh, slow pointer, and next of all let me take so this one as slow, yes, and for fast so I'm taking safe. Okay, initially so slow pointer so we'll take to head. Okay, and fast pointer also so get initialized with head address. Okay, next see uh, with the terminology itself you can easily understood so that so how we are going to update so these pointers here. Okay, so in different two-pointer approach programs, so we update so pointers in different way, so already observed in arrays topic also. So here so slow on updating to the next location, so fast so we'll update to the next of next location, so means it moves one node ahead when compared to that. So likewise by repeating so this we are going to get the So exactly middle node. How we are going to get means so understood with the help of this example. Okay. Next, likewise, let us repeat now. Okay. Now again on updating so slow pointer to the next location, what happens? So slow moves to the so node 3, right? Okay. And so the fast moves to the so node number 5, right? Okay. So node having value 5 or else node number 5. So whatever you can take. Okay. So now observe here. So fast finally reach to the so last node here. Okay. On reaching so fast pointer to the last node, you can observe one thing here. So the slow pointer is exactly pointing to the middle node of the linked list. Okay. Uh, so see how easily we can so finish this. You can check now. Okay. So whenever fast reaches to the so last node, so on returning so the slow pointer, so exactly we are so we're going to return the middle node. Okay. So what is the condition? We have to frame. So till by what time actually these slow and fast pointers has to be updated. That condition. So we need to take. Okay. So whenever so the fast next is null. Okay. Fast next is null. We need to stop it. Okay. And stopping traversing and returning slow. Exactly it is going to return. Uh, so the slow pointer that is exactly middle node. Okay. So this is about odd length linked list, guys. Okay. So I hope so you understood this one. Next. So let me explain for even length linked list now. Okay. Have a look. 1, 2, 3 node next to 4 and 4 node next to 5 and 5 node next to 6 and 6 node next to 2. So null. Okay. So this is the head address, guys. Okay. So what we'll do, first of all, slow pointer and fast pointer. So we'll take to the head node, right? Okay. So slow on updating to the node 2. So fast pointer, so we'll update to the next of next. Okay. Fast pointer, we update to the next of next node. Okay. So again, slow on moving to the, so node number 3. So slow moves to the, slow moves to the next of next node, that is to the node number 5. Okay. So now if you observe, so slow is exactly pointing to the first middle node, okay, in the even length linked list. But so what we want, so according to the lead code problem statement, we want so this one, second middle node in the linked list, right? Okay. So means let us move slow pointer to that node, okay. So let us check. So to where fast pointer is going to be updated, okay. So based on that, actually we are going to take the condition now, okay. So slow pointer on updating to so here so fast pointer. So what happens? So it is going to reach next of next. Next of next means it's nothing but null. Okay. So whenever so fast pointer reaches to the null. Okay, and on stopping and returning, so exactly we are going to return so the so middle node, second middle node in the so linked list. Okay. So I hope she understood. So actually to our program, so different inputs are going to be passed, right? Okay. So to our program, so even length linked list might be passed or else so the odd length linked list might be passed. Okay. So our program should work for so the all types of linked list, right? Okay. So for that sake, so we should be careful. So here for while taking so the conditions where we need to stop so for particular type of linked list. Okay. So here for even length linked list, so we need to stop whenever fast reaches to the so null. Okay. So but here, so for odd length linked list, fast we should stop. So at the last node in the linked list means whenever we found the fast next is null, we need to stop here. Okay. So but here in even length linked list, so we should stop whenever so the fast reaches to the null here. Okay. So means here, so actually while working with the adjacent values program, so repeatedly I mentioned this, okay? While we are working with current and next, so position values, we need to stop at the So last but one position itself. Okay. So here, which pointer so moves so here first pointer, so null on pointing to the null, we need to stop it, and fast next on pointing to the null, we need to stop it. So first, which one we need to check? So means first we should take so the condition called fast not is equals to null. Till by that time, so we should keep on repeat of so moving to the nodes. Okay. So next, so this one fast next, so not is equals to none. We should take so the next to the so this condition fast not is equals to none. Why? Because means listen. For suppose if we take fast not is equals to fast dot next to not is equals to null. Okay. So for this even length linked list, so what is going to be happened? So it is going to check so null dot next. Okay. So is null dot next is available? No, right? So we are going to get so null pointer exception. Okay. Null pointer exception. So we are going to get, okay. So with the help of, if we take so this condition, so null means fast dot next condition. So if we take not is equals to null in the beginning, after that, so if we take fast not is equals to null, if you take like this, okay. So for this even length linked list, what happens finally? So after reaching so the fast pointer to here, so slow pointer, so exactly slow pointer exactly pointing to the second middle node in the linked list, right? In that scenario, what happens? It goes for checking. So this one, okay. So we are going to get the error, okay. So but if you interchange, so these two conditions now you are not going to get any type of errors, okay. So means we should take conditions like this, guys, okay. Once after checking so the previous node only, then only we should go for so checking condition so relevant to the next node. So remember this, okay. This is very important. Remaining part is easy here. Only you need to focus on how to take so the conditions here, okay. Uh, while fast not is equals to null, and after checking whether fast pointer is not pointing to null, then only we should go for checking so the fast dot next, so not is equals to null. If fast itself is pointing to null means, so yes, there is no possibility of checking so the fast dot next to not is equals to null. Okay. So I hope you understood. This is the logic. Okay. For so now what happens for odd length linked list? Okay. So here this fast it is not is equals to null, right? Okay, but fast dot next not is equals to null, it is false. So whenever it is false, we are going to stop the loop and return the so middle node. Okay. So and for even length linked list, so what is going to be happened here? Fast not is equals to null means this condition itself becomes a false. Based on this, it is going to return the so second middle node of the linked list. Okay. So slow initially, so we are taking to head. Okay. Let us take so like this, slow to head address, and fast also we'll take it to the head address. Slow we update to the so the next location means until these conditions so becomes true. Okay, so we keep on repeat this process. Fast we update to the next of next location. For suppose if this condition becomes so false, and it stops the loop. Okay. So what is meaning of that? It is the even length linked list. So outside of the so while loop, we are going to return slow node address. Okay. So that it is going to return the second node so address, that is 4. Okay. For suppose if this condition becomes so that true for odd length linked list, what happens finally? So fast is still not pointing to null, but fast next is pointing to the null, right? Okay. So in that scenario, what happens? This condition so becomes true, but this condition so fails. Based on that, it is going to stop the so loop, and so it is going to return the slow pointer address. Okay. So I hope so you understood this one. Okay. So let me complete So the programming part for this one, okay, it's a very easy one, okay. Slow we should update to the next location, fast to the next of next. Once after completion of the loop, we need to return the slow address. Always start is wins, okay. So here also with the help of slow pointer only, we are returning so the middle node here, okay. Initially we should take slow and fast pointers to the head address. Only the thing is we should be careful. So while taking these conditions, which condition we should take? So in the beginning and what condition we should take? So next of all, you need to remember here. So let me complete. So this one. So I'll type in Python. Okay. So you try to convert into the so remain language, guys. Okay. So observe here already in solution class. So middle node method is given. Head address passed here. Okay. So it we need to return some list node here. Okay. So find what is the first step? Slow pointer. So we should take to the head, and fast pointer also initially we should take to head. Okay. So first we should check fast not is equals to none and fast dot. If that is true, okay, then you should go for checking so whether fast dot next is none. So for odd length linked list, so we are taking fast dot next, and for even length linked list, we are taking fast dot is equals to none. So in that scenario, what we'll do is, if still not pointing to the one, as slow we update to the next location, and fast, so we'll go for updating so to the next of next. Okay, this is the meaning, right? If fast next is not none means yes, then so that we can take here and we going to go for updating fast to the next of next. Okay, so based on taking updation statements here inside the loop, also you can decide how we should take so the conditions in the loop. Okay. So fine. Once after completion of so the loop, we need to return so the slow node address here. Okay. So let us check so whether it works or not. Let us run and submit as so base case completed. Let us submit now. Observe everyone. Yeah. Taken 0 milliseconds and beaten 100% of all solutions. Okay. I hope so you understood this one. So now let me complete so this one also, guys. Okay. Returning first middle node. Okay. So means let us take so this 1, 2, 3, 4, 5, and so 6. Finally, it is pointing to the none. Okay. So this is the head address, and slow and fast pointer we take into here. Slow and moving to here. So fast we updated to node number 3. Slow and updating to node number 3. Fast we updated to here. Okay. So now we need to return so the first middle node in the even length linked list, right? Okay. So for odd length linked list, so what is the condition? Fast dot next to not is equals to null, right? Okay. Null or else none. Okay. So here on returning, so the slow node value, so that is called 3, first middle node. Okay. So we need to stop fast here. Okay. So that so we can return the slow node so value that is called 3. So where we need to stop this one here. So fast next is not null and fast next dot next is none. Whenever we found that fast not next dot next is none, then we need to stop it, right? Okay. So what is the condition for so checking for returning so first middle node in the even length linked list means fast dot next. So if it is not is null, so we should keep on update. First of all, fast we update to here. So we'll check whether fast next dot next is null or not. No, it is not null. As fast we updated to here and slow we updated to here. So, but now fast next dot next means it's a null. Okay. So yes, we do not so perform any operation further. We do not repeat the loop. We stop it and so return the middle node. Okay. So now among these two conditions, so which condition so we need to take in the beginning means okay. So this one comes first, right? Fast dot next. Afterwards we get which if it is not pointing to null, then only there is a possibility of comparing. So fast dot next null. Okay. I hope you understood. So this is for so odd length And so this is for, don't confuse, okay? So observe everyone carefully. Even length, so first middle node it is, okay? For suppose what we taken so previous, okay? Fast not is equals to null and fast dot next not is equals to null we taken, right? Okay. So this fast not is equals to null we taken for even length linked list. So returning, so second middle node in the even length linked list, right? Okay. Second middle. But and this one, so it's for odd length, okay? See, it's reversed here. Earlier we taken first of all even length condition and afterwards so odd length condition. But now first we should take so the odd length condition, next of all so the even length condition for returning the first middle node because we need to stop at the before node itself, okay? So let me complete so this one also now. Let us take so the another platform so called WorkerTech. In this WorkerTech platform, so I'm opening middle element of linked list. Right side you can observe in how many companies so this one so asked, okay. So or else here also you can check in Coding Ninja's platform. I'll show you the middle node of linked list. Check here. So this one asked in 56 plus companies, guys, nearly. Okay, so it's very important. Okay, so based on this, we are going to observe detecting cycle in the linked list, detecting starting point of the cycle linked list. So palindrome program. So all this we are going to finish. So with the help of this slow and fast pointer terminology, that's why it's very important. Now let us see from the WorkerTech platform here. Let us see. So from Coding Ninjas, okay. So what is given? Let us see now. So here also they asked us to return the second middle node. But like if you take a WorkerTech platform, so what they have asked, so check everyone. If list has even number of elements, so print first of the two middle nodes. Okay. So I hope you understood. That's why you should have so the knowledge on both the things. Just condition changes, everything remains same, guys. Okay. So let me complete this. Okay. First, here get middle element of linked list is given, head address passed, and we need to return so the integer value here return. Observe here from platform to platform, so this one differs. There we need to return so node address, but here we need to return so the so node value here. That's why it is better to practice so the same program in different platforms. So check whether so you can cope up with so different platforms or not. Okay, by adopting those changes whether you can execute or not. Variables, so names changes, okay, return types changes, okay. So problem statement also changes. So here you observe we need to return the first middle node. So for working with all this, okay, to understood all this, okay, you need to practice the same program from the different platforms, okay. So I hope you understood. Now let us complete. So slow pointer initially I'm taking so the to head and fast pointer also I'm taking to head. Okay. So now what is the condition? So for odd length linked list, we need to take so this. Okay. So if it is not none, and for even length linked list, we need to fetch the first middle node. Okay. So that's why we need to take so this one fast dot next not is equals to none. If it is true, as we go for updating slow pointer to the next node, and so fast pointer, so we go for updating to the next of next to node, guys. Okay. So whenever we found any one of these conditions, so becomes so false. Okay, we need to return so the slow node data here. Okay, data variable is given, and this one also changes in lead code platform. So value variable name is value is given val. Okay, here it's given data. So be careful with all this terminology. Node definition is given in the top, okay, in each and every platform. So gone through that based on that. So use the pointers and so variable values, okay, and so return slow dot so data, guys, okay. Let us check whether so it works or not now. Observe everyone. As base case executed. Let us submit now. Okay. Yeah, fine. It's working. So I completed so the both the solutions here. So getting middle node, first middle node in even linked list and second middle node in even length linked list. Okay. So I hope so each and everyone understood so this one. If you have any doubts regarding so this one, okay. So ask with me. I'll clarify your doubts. Okay. So that's it for this video. So thank you everyone. Let us meet in the next video, guys.